Good day once again, class. We will be discussing all about the polarity of molecules in this topic. So let us define first what is meant by electronegativity. So as you can see from the picture, there are three small balls. So actually there are two small balls and one big ball. So as you can see there, the big ball in color blue is handling a magnet attracting the two smaller balls. So this is how we can illustrate what electronegativity is. So as you can see, electronegativity is a chemical property that describes the tendency of an atom or a functional group to attract electrons towards itself. That is why you can see a magnet being held by the bigger circle, which symbolizes the atom or the element. Now, you might wonder where electronegativity values can be found. As you can see from our slide today, you can see that the electronegativity values of elements can be found in the periodic table of elements. Now, if you want to search for the electronegativity values, just have to look for it in the periodic table of elements. Now, take note that way back in your grade 8, you have studied all about the development and the trends found in the periodic table of elements. Now, as you can see here in the slide, there is a certain trend to be followed with regards to the electronegativity of elements found in the periodic table. Now, from the upper part portion, you can see there that from left to right, there is a trend of increasing electronegativity. The same way that if it is found from bottom going up, electronegativity of elements also increases. Now, remember way back in your grade 9, you have studied all about chemical bonding. There are three types of chemical bonds. We have ionic bond, which is the bond between metal and non-metal. We also have covalent bond, which is the bond between non-metals. And we also have metallic bond, which is the bond between two metals. Now, what is its connection with the electronegativity difference and bond types? Now, as you can see here on the screen, you have here the electronegativity difference range, the most probable type of bond, and the example. So say for example, the electronegativity difference range is from 0 to zero point 0.4. That chemical can contain a nonpolar covalent bond. One good example is the bond between hydrogen atoms. The second type is zero point 0.4 to 1 is considered as moderately polar covalent. When we say moderately polar covalent, medyo mahina pa yung mga partial charges. One good example is hydrochloric acid, a combination of hydrogen and chlorine, which has an electronegativity difference of 0.9, which can be considered as moderately polar covalent. The next one is 1.0 to 2.0. These are considered as very polar covalent. One good example of a compound with a very polar covalent is hydrofluoric acid. It's a combination between hydrogen and fluorine. Now, if you can compute the electronegativity difference, the difference is 1.9, which is under a very polar covalent. And the last type is more than, equal, or more than 2. That is already considered as an ionic bond. One good example is sodium chloride, combination between sodium and chlorine. Once you get the electronegativity difference between sodium and chlorine, the answer would be 2.1. And that leads us to conclude that the compound is ionic. Now, how to solve for the electronegativity difference? So we have here 4 steps to follow in order for you to get the electronegativity difference. So the step 1 is to look for the electronegativity values of the element in the periodic table of elements. So if you have a physical periodic table of elements, nandoon yan sa maliit na kanto nakalagay yung electronegativity values. But then if you don't have the physical copy of the periodic table of elements, you may download an app for the periodic table of elements. Nandun na lahat ng values na kailangan yung malaman. So we have here an example. An example of compound is H2O, or water. Now, the electronegativity value of hydrogen is 2.1. And the electronegativity value of oxygen is 3.5. So if you are already able to locate these in the periodic table, you are now ready to go for the step 2. Now, step 2 means subtract the electronegativity values. Kahit magbalik-balik ta rin mo, basta yung value mo, makuha mo kasi we are just after the difference. So, 3.5 minus 2.1, the answer is 1.4. Now, what is this 1.4? This 1.4 now is the what we call electronegativity difference. You need that in order for you to go to step number 3. And so step number 3 is compare the difference to the bonding range. Remember in the previous slide, meron tayong bonding range and then kung ilan yung value ng bonding range, nandoon yung type of chemical bond na meron doon. Kasi for example, ito yung bonding, yung electronegativity values na is 1.4 as you can see here. The electronegativity values for H2O is 1.4. So, babalik ka doon sa previous slide, tingnan mo yung bonding range. Ito yung bonding range niya, o ayan. From 0.5 to 2.0, that's the bonding range. Ano ba itong klase ng chemical? Ano ba itong klase ng chemical bond? So you have to go to step number 4. Identify the type of bond. So balikan natin yung hydrogen, dihydrogen oxide or water. 1.4 yung difference niya. Pumapasok siya ngayon sa bonding range na 0.5 to 2. And so that means water is a type of polar covalent bond. Opo, na-gets. So, if malabo pa, you can still look for other compound and try to compute the electronegativity difference and try to classify if it's a polar covalent bond or ionic bond. Now that you know how to calculate the electronegativity difference of compounds, you may now answer activity 2 for the molecular polarities. You can pause this video if you want, or you can go back to the previous slide in order for you to understand how to calculate the electronegativity difference between elements in a compound. Now, moving on with our lesson, it is important that you know the difference between a polar bond and a non-polar bond. A polar bond occurs when electron pairs are unequally shared due to the difference in electronegativity of the atoms. Remember that electronegativity is the ability of an atom to attract another atom. So, when there is unequal sharing of electron, then polar bonds happen. The greater the electronegativity between the two atoms, the more polar their bond is. Now, a nonpolar bond, on the other hand, develops if both atoms equally share a pair of electrons between them. This happens when the bonding atoms have approximately equal ability to attract electron on each side. So sa polar bond, merong hindi equal na charges. Kaya hindi siya masyadong kaya siya naging polar. Sa non-polar bond, equal sharing kaya naging non-polar siya. Now that you know the difference between a polar and non-polar bond, it is important that you know the molecular geometry. So the molecular geometry is explained by VSEPR, the valence shell electron pair repulsion theory. Now, as you can see on your screen right now, you have there an example of a molecule that is not planar or 2D in example. It's actually in 3D because in real life, molecules are actually 3D. Hindi lang siya naka-flat lang sa surface. Three-dimensional din siya. So that is why we have this picture on your screen. Now, what is molecular geometry? So the molecular geometry in chemistry is represented by the VSEPR or the valence shell electron pair repulsion theory. Now, what is molecular geometry? It refers to the three-dimensional arrangement of atoms in a molecule. So as I was saying in the previous slide, atom is not two-dimensional, it's always three-dimensional. Now, what is VSEPR theory? It is used to predict the arrangement of electron pairs around central atoms in molecules, especially simple and symmetric molecules. So you will know this later because I will be presenting you a table for you to base your answer as to what type of molecular geometry a certain molecule has. These are the key ideas of molecular geometry or the valence shell electron pair repulsion theory. Number 1, electron pairs stay as far apart from each other as possible to minimize repulsion. So in Tagalog, yung mga electron pairs daw, medyo malayo sa isa't isa para maiwasan yung parang pagbabanggaan or parang O parang gano'n, para hindi sila hindi magpanggaan, para hindi sila stay away, far from each other, something like that. So number two naman, molecular shape is determined by the number of bond pairs and lone pairs around the central atoms. So take note, yung molecular shape daw na didetermine gamit yung number of bond pairs, yung nag-bond sa ibang element, while yung lone pairs naman yung walang kabanding sa central atom. So we'll have this later. Number three, treat multiple bonds as if they were single bonds. Yung mga multiple bonds, consider muna natin as if single bond lang muna sila. And then number four, lone pairs occupy more than bond pairs. Mas marami na occupy ng lone pairs kaysa sa bond pairs. Now, in order for us to understand the difference between lone pairs and bond pairs, we have here on the screen the difference between the two. As you can see here on the screen, we have hydrogen and chlorine. Now, when hydrogen and chlorine bond, hydrogen only have one valence electron based from its electronic configuration. Kung babalikan nyo yung lesson nyo noong grade 9 kayo, tinuruan kayo ng mga teachers nyo kung paano magsulat ng electronic configuration. And then once you are done writing the electronic configuration, dapat ma-identify mo yung valence electron. And what is valence electron? Yung valence electron, siya yung electron na matatagpuan sa outermost energy level. So, ganun yung nangyayari. So, in the case of hydrogen, meron lang naman siyang isang electron. So, meaning to say, yung outermost electron or yung valence electron niya is only one. That's why, in the Lewis dot notation, yung hydrogen, meron lang siyang isang dot. Ayan yung dot niya. So, for chlorine, yung chlorine naman, pag sinulat mo yung electronic configuration niya, you will be using 35 because that's the atomic number. And then yung valence electron niya is 1, 2, 3, 4, 5, 6, 7. 7 ang valence electron niya. So, if you are going to write the electronic configuration and identify the number of valence electron. Pero merong mas madali niyan. Tingnan nyo kung meron kayong periodic table of elements, tingnan nyo doon kung anong group number niya. Say for example, for hydrogen, hydrogen is found in group 1, yung group yung pababa. In group 1A, meaning to say lahat ng elements sa group 1A has one valence electron. Ito naman chlorine, nasa group number 7 siya sa periodic table. Lahat ng element na matagpuan sa group number 7, lahat yan merong 7 valence electron. So now you know, mas madali, hindi na kayo may electronic configuration, titingnan nyo lang yung periodic table. Ay, nasa group 1 ngaya siya, so meron siyang 1 valence electron. Ay, nasa group 7 ngaya siya, so meron siyang 7 valence electron. Okay, now that you know the valence electron of hydrogen and chlorine, it is now time for us to identify what are the bond pairs and what are the lone pairs. Now take note, for an element to be stable, it needs to follow the octet rule. The octet rule is simply saying to us that an element must have 8 valence electrons or it must follow the configuration of the noble gases na merong 8 valence electron. Exception for hydrogen and neon, kasi yung hydrogen, for it to be stable, dapat magaya niya yung configuration ng neon, which has 2 valence electrons. Now, take a look at the illustration on your screen. Now, this illustration on your screen illustrates the difference between lone pair and the bond pair. Tingnan nyo. Yung electron ng hydrogen sa nag-iisang electron ng chlorine, nagkaroon sila ng bonding. Kaya ang tawag sa kanila bond pair. Yung the rest na mga electrons ng chlorine, walang kabanding sa hydrogen. That's why ang tawag sa kanila lone pairs. Ayan o, 2, 4, 6, 8. It achieved the octet rule, so meaning to say hydrochloric acid is already stable. But take note that the bond pair is the one between chlorine and hydrogen, and the lone pairs are just the electrons in the chlorine atom. Now, as you can see here, the definition of lone pairs is an electron pair in the outermost shell of an atom that is not shared or bonded to another atom. Ayan yon. And then on the other hand, we have the definition for bond pair. A bond pair is a pair of electrons that are in a bond. So very simple. The table you are seeing right now on your screen is the table that will help you to identify the molecular shape of a certain molecule. Now, the LP here stands for lone pair. BA here is something like bond pair. And then the parent shape here, as you can see, we have linear, trigonal planar, tetrahedral. And then the molecular shape in here is described. And then here is the picture of the molecule. Let's disregard the angle first. So say for example, we have identified in the molecule of the you have identified in the molecule that there is no lone pair, so that is 0. And if there are two bonded pair, then you can say that the molecular shape of that molecule is linear in nature, as described in this picture. This is an example of a linear molecule. Now, if you see that there is no lone pair, but there are three bonded pairs, now the parent shape would be trigonal planar. And then the molecular shape would be trigonal planar, just like this one. This is the parent molecule, letter E. And as you can see here, there are three bonded pairs. 1, 2, and then 3. So pag ganyan yung nakita yung molecule, the molecular shape would be trigonal planar. Na pero kung meron siyang isang lone pair, tapos dalawa yung parent shape niya, yung shape niya medyo bent. That's why ganyan, no? This is the lone pair. Ayan, kaya dalawang dots. And then ito naman yung dalawang bonded pair. And so you can say that the molecular shape would be trigonal planar pero bent. Kasi merong nagko-cause ng pag-bend niya yung mga lone pairs kasi meron niyang mga partial charges. Now, paano naman kung wala siyang lone pair pero apat yung bonded pair niya? So the parent shape would be tetrahedral. Pero what is the molecular shape? So the molecular shape would be tetrahedral also, just like this one. Ayan. So wala siyang lone pair pero meron siyang bonded pair na apat. 1, 2, 3. Ang hirap isulat. 3 and then 4. Amo po. Ito naman yung another one. Paano naman, sir, kung merong isang lone pair tapos tatlong bonded pair? So, tetrahedral pa rin yung parent shape niya. Pero yung molecular shape niya would be trigonal pyramidal. O, parang pyramid. Ayan yung lone pair nasa taas. Ito naman yung tatlong bonded pairs. As you can see, it's bonded in X. So, paano naman ngayon, sir, kung dalawa na yung lone pair? Ayan, may dalawang lone pair, merong dalawang bonded pair. So, the parent shape would still be tetrahedral, pero the molecular shape would be bent. Ayan, medyo bent siya, na parang ganyan. Guidelines for applying the VSEPR model. Number 1, write the Lewis structure of the molecule, considering only the electron pairs around the central atom. So remember way back in your grade 9, you are taught how to write Lewis dot notation or Lewis structure in order to designate that a certain molecule contains covalent bond. Now, we will have a review of this later. Number 2, count the number of electron pairs around the central atom. Treat double and triple bonds as though they were single bonds. Number 3, use table 2 to predict the geometry of molecule. Yung table kanina sa previous slide, yun yung gagamitin natin para malaman natin yung geometry of the molecule. So, di ba tinignan na natin kanina, nandoon na yun para ma-predict. Number 4, in predicting bond angles, note that a lone pair repels another lone pair or a bonding pair more strongly than a bonding pair repels another bonding pair. Okay, so paano ba to? Tingnan natin sa next slide. Now, as you can see on your screen, we now have the example. This example was obtained from your modules. So let us try to see and use the VSEPR model in order to predict the geometry of the molecule. So we have here example number 1 only. So you are going to predict the molecular geometry of water, which is H2O. So here is the solution. We follow the preceding procedure for constructing the VSEPR model. Eto na. So number 1, draw the Lewis structure of water. So if you can see, parang linear lang yung model kasi hindi pa natin alam kung paano yung magiging molecular geometry niya. So using your knowledge of electron dot notation way back in grade 9, you know very well that hydrogen has one valence electron, and so that makes hydrogen with one dot only, while oxygen belongs to group 6 elements. So that means it contains 6 valence electrons. That's why it contains 6 dots around its symbol. Now, since hydrogen and oxygen forms covalent bond, because hydrogen is non-metal and oxygen is also non-metal, so if it is a combination of two non-metals, the resulting compound is a covalent compound. And so since covalent compound uses sharing of electrons, then hydrogen and oxygen will then share their electrons in order to arrive at the octet rule. Pag sinabi octet rule, 8 valence electrons. So that means yung oxygen and hydrogen mag-share ng tig-isa, share ka 2, 4, 6, 8. So there are 8 valence electron now, meaning to say it has already arrived at the octet rule. So wala nang problem, it's already stable. And so let's have now step number 2. Count the number of electron pairs around the central atom. There are 4 electron pairs around the central atom, 2 bond pairs, and 2 lone pairs. Now, let me show to you the different bond pairs. Ito yon. So, ito yung number 1 kasi pair dalawa yan. 1, 2, and then the other one is this one, 3, and then 4. So there are a total of bond pairs around the central atom. But then let us identify which from them are the examples of bond pairs and which are the examples of lone pairs. Yung bond pairs, yan yung merong guhit. Ibig sabihin kasi nakikovalent bonding siya sa another element. Kaya merong guhit. So this one can now be considered, as bond pair. That's bond pair number 1. This one is bond pair number 2. Saan naman yung lone pair? Yung lone pair naman, yung mga hindi nakibonding. Ito yon. 1 and then 2. There are 4 total, but then there are only 2 bond pairs and there are also 2 lone pairs. So that leads us to step number 3. So number 3 naman, use tables 2 to predict the geometry of the molecules. The arrangement of electron pairs are tetrahedral. Now using the table 2, yung previous slide, tetrahedral yung arrangement niya. Based on so you will use only the lone pairs and bond pairs. Meron 2 bond pairs and then 2 lone pairs. Tingnan nyo doon sa table kung saan siya tumutugma siya ngayon sa arrangement na tetrahedral. And then that leads us to number 4. Number 4, determine the molecular geometry. Since the 2 lone pair is not considered, since this cannot be seen, therefore, the molecular geometry is bent. If you are going to go back to our previous slide, ang nakalagay doon, pag meron daw 2 lone pairs, and meron namang 2 bond pairs, which is tetrahedral, yung arrangement ng molecule niya is bent. And that leads us to step number 5. Draw the molecular geometry as shown in table 4. Ganyan, bent na siya. Hindi siya linear because of the presence of the lone pairs. Ayan, may mga lone pairs tayo dyan. So I hope you're able to get it. So in order for you to remember how to draw the Lewis structure, I am now showing you on your screen how to draw a Lewis structure. There are 4 easy steps. Number 1, find total valence electrons. There are many ways on how you can count the number of valence electrons of an atom. Number 1, you write the electronic configuration and you identify the last orbital, then you will be able to get the valence electron there. Number 2, you get your periodic table, you identify what group of element that element belongs, and the number corresponds to the number of valence electrons. Say for example, hydrogen belongs to group 1 element, meaning to say it has 1 valence electron. Ganon. Say for example, neon. Neon belongs to group 8 element. If you have your periodic table, you can check. Then that means neon has 2 valence electron. Neon is actually the exception. But if you will see radon and xenon, it contains 8 valence electrons. Okay, number 2, draw a skeleton structure using single bonds. Ayan, ito yung example ng skeleton kasi nakipag-bond yung oxygen sa nitrogen. Ayan pa, and then ayan pa. Parang kinonect lang. And then number 3, assign remaining valence electrons. Halimbawa, yung oxygen, meron kasi siyang 7 valence electron. Isa lang yung nakipag-bond sa nitrogen. Meaning to say, yung iba, lahat siya lone pairs. Ayan, 1, 2, and then 3. And the number 4, make multiple bonds if all octets aren't filled. So, halimbawa itong nitrogen, o ayan, tingnan mo, 1, 2, 1, 2, 4, 5, 6, o kulang pa, nakipag-double bond siya sa isang oxygen. So, that means 2, 4, 6, and then 8. Na-fulfill niya na yung octet rule. So, meaning to say, this is the final Lewis dot structure of the compound. You can go back to the previous slide so that you may be refreshed on how to write the electron dot notation and how to identify the molecular geometry, how to draw the molecular geometry of a certain compound. So this time, you may now post this video and be able to answer activity number 4, which is entitled Molecular Architecture. If you have questions, you can directly message me via Messenger. Now, continuing with our lesson, here are some points to remember to determine the polarity of molecules based on the geometrical arrangement of molecules. For nonpolar molecule, the shape of the molecule is symmetrical. Ibig sabihin, there is equal sharing of electrons. Number 2, the central atom does not have lone pairs. Lahat nakibond. Thus, all its electrons were equally shared to another atom of the same element. So a while ago, we have mentioned about the nonpolar molecules. Now this time, we have the points to remember in order to determine the polarity of molecules for polar molecules. Ito naman yon. For polar molecules, the shape of the molecules is asymmetrical because there is unequal sharing of electrons. Number 2, the central atom or one of the central atoms has lone pairs. And then number 3, the central atom does not have lone pair but bonded to atoms of different kinds. And with that, I know that you would be able now to identify the polarity of the molecules. And so at this point, you may now answer activity number 5, which is the polarity of molecules. You can pause this video and go back to the previous videos in order for you to be refreshed on how to answer those questions.